June 8, 1944. 1340 hours. Open farmland, 3 miles inland from Gold Beach, Normandy. Oberleutnant Karl Brenner commanded a reinforced strongpoint overlooking the approach to Bayeux. 3 machine gun positions, 2 anti-tank guns, and a carefully prepared minefield extending 200 meters across the only viable avenue of approach. His orders were simple: hold until relieved or destroyed. The British armor visible in the distance represented exactly the threat his position had been designed to stop. The first Churchill tank advanced cautiously, scanning for mines. When it struck one, the explosion lifted the 30-ton vehicle and shattered its tracks. The crew abandoned immediately, scrambling for cover as Brenner's machine gunners opened fire. The British armor halted. Infantry took cover in drainage ditches. The attack stalled exactly as German defensive doctrine predicted. Brenner permitted himself brief satisfaction. The minefield was performing precisely as intended, creating a killing zone where British armor couldn't advance and infantry couldn't follow. Every mine his engineers had buried was paying dividends. The British would need days to clear a path through that field, and Brenner's machine guns would ensure that clearance teams never survived long enough to complete the work. Then he heard a sound unlike anything he'd experienced in 2 years of combat. A mechanical roaring, overlaid with rhythmic metallic impacts that suggested some massive engine-driving machinery at impossible speeds. Through the smoke from the burning Churchill, a Sherman tank emerged, but its appearance made no sense. The front of the tank sprouted a massive rotating drum from which dozens of chains whirled like some medieval flail enlarged to industrial scale. As the tank moved forward, the chains hammered the ground with such force that earth and debris flew in all directions. The tank entered the minefield. Brenner expected the inevitable explosion. Instead, the chains detonated a mine. The blast absorbed by distance and earth, and the tank continued forward without pause. Another mine exploded under the flailing chains, then another. The tank was deliberately triggering mines while remaining far enough back that the explosions couldn't damage its tracks or hull. "What in God's name is that?" Brenner's gunner asked. Brenner had no answer. In his entire military education, nothing had prepared him for a tank that could advance through a minefield by detonating every mine in its path. The concept seemed insane, deliberately triggering explosions mere meters from your own vehicle. Yet the machine kept coming, the chains beating the ground in relentless rhythm, clearing a path as precisely as if engineers had worked for hours with mine detectors. Behind the strange tank, British infantry began moving forward, staying carefully within the cleared path. Then more armor appeared, following the exact route the flail tank had opened. Within 10 minutes, an entire British column was advancing through what had been an impenetrable minefield. The obstacles Brenner had counted on to stop them rendered completely irrelevant by a single, bizarre machine. Brenner ordered his position abandoned. There was no point remaining when the British could simply drive through his defensive preparations as if they didn't exist. The mine problem that demanded impossible solutions. By 1944, German defensive strategy across Western Europe depended fundamentally on mines. The Wehrmacht lacked sufficient infantry and armor to defend every kilometer of front line through manpower alone. Mines provided force multiplication. A few engineers could create obstacles that would stop entire battalions, buying time for mobile reserves to respond to Allied breakthroughs. The statistics documented German reliance on these weapons. In Normandy alone, German forces laid over 6 million mines of various types: anti-tank weapons designed to destroy tracked vehicles, anti-personnel devices intended to kill infantry, and specialized obstacles meant to channel attackers into prepared killing zones. Some fields contained more than 2,000 mines per square kilometer, laid in overlapping patterns designed to ensure that clearing any path would require triggering multiple devices. For attacking forces, mines represented nightmares that couldn't be solved through firepower or courage. Artillery couldn't reliably detonate buried mines. Armor couldn't advance without tracks. Infantry couldn't clear paths under fire. Mine detection required soldiers to work slowly and methodically while completely exposed to enemy guns. Every approach to German positions became a choice between suicide by mines or suicide by attempting to clear them under German observation. Traditional mine-clearing methods had proven inadequate during the North African campaign. Engineer teams advancing with mine detectors died in appalling numbers. Explosive charges pushed ahead of tanks sometimes cleared narrow paths but couldn't be used at scale. Rolling devices designed to trigger mines ahead of vehicles were too fragile and couldn't function in soft soil or mud. The British needed a solution that could clear wide paths through dense minefields while under direct fire, operated by tank crews rather than exposed infantry. The answer emerged from the Specialized Armor Development Program, overseen by Major General Percy Hobart, an eccentric officer whose unconventional ideas about armored warfare had gotten him effectively retired before Churchill personally recalled him to command Britain's specialized armor development. Hobart's approach was simple: identify problems that stopped armored advances, then design vehicles specifically to solve those problems regardless of how strange or impractical the solutions appeared. The mine flail concept wasn't new. Experimental vehicles with rotating drums and chains had been tested during the North African campaign with mixed results. But Hobart's team refined the design, mounting a sturdy mechanism on the reliable Sherman chassis and solving the mechanical problems that had plagued earlier versions. The result was designated the Sherman Crab, a name that perfectly captured the vehicle's ungainly appearance and sideways approach to problems. The machine that looked like madness. The Sherman Crab appeared to violate every principle of armored vehicle design. A massive drum mounted ahead of the tank's hull carried 75 heavy chains, each terminated with a large steel ball. Hydraulic motors spun the drum at 140 rotations per minute. As the drum rotated, the chains whipped outward and struck the ground with enough force to detonate buried mines at safe distance from the tank itself. The system transformed the Sherman into something that barely resembled a tank. The drum assembly added several tons to the vehicle's weight and substantially reduced its speed. The rotating chains created noise that could be heard for hundreds of meters. Most critically, operating the flail created a spectacle that seemed designed to attract every enemy weapon in range. The tank literally announced its presence through continuous explosions and flying debris. German soldiers who first encountered crabs reported profound confusion about what they were witnessing. The tank would enter a minefield and simply keep moving while explosions erupted continuously beneath the flailing chains. From a distance, the vehicle appeared to be under constant attack, with earth and shrapnel flying in all directions. The violent shaking caused by the drum's rotation made the tank seem to dance or stagger as it advanced. German gunners initially assumed the vehicles were damaged or malfunctioning. That assumption lasted only until they realized the damaged tank was systematically destroying every mine in its path while clearing a route precisely wide enough for following armor and infantry. The chains struck the ground in overlapping patterns that ensured complete coverage. Side cutters removed wire obstacles. The system worked in mud, sand, and waterlogged soil that defeated other mine-clearing devices. Most remarkably, the Crab could operate while under fire. The crew remained protected inside the Sherman's armor, while the external mechanism performed its violent work. British crews selected for Crab operations understood they were volunteering for the most dangerous job in armored warfare. Every mine detonated by the flail exploded mere meters ahead of the tank. The drum assembly partially obscured forward vision. The noise made communication difficult. Operating the flail required precise speed control. Too fast, and the chains wouldn't strike deeply enough to trigger mines. Too slow, and the tank became an easy target. Crab commanders led from the very front of every armored advance, always first into minefields, always most exposed to German fire. The training emphasized maintaining forward momentum regardless of what happened. If the flail struck a mine, keep moving. If German guns opened fire, keep flailing while the supporting armor engaged them. If the drum jammed, attempt field repairs under fire, or abandon the vehicle and move to the backup Crab. The entire tactical concept depended on Crab crews accepting that their job was to clear paths no matter what, trusting that following forces would exploit those paths quickly enough to justify the risks. Normandy, the dancing tanks arrive. The first combat employment of Sherman Crabs occurred during the initial hours after D-Day landings. British and Canadian forces, equipped with the specialized armor, collectively known as Hobart's Funnies, brought capabilities that American forces lacked. While American armor struggled with obstacles and minefields on Omaha and Utah beaches, British forces on Gold, Juno, and Sword beaches employed Crabs to clear paths through coastal defenses. The results validated years of development work. Crabs advanced directly through minefields that should have stopped armored advances for hours or days. Some vehicles cleared over 100 mines in 30-minute operations, creating paths that entire battalions could use safely. German defenders reported surprise and confusion. They'd positioned mines specifically to stop tanks, yet British armor was advancing through fields they'd considered impassable. The psychological impact matched the tactical success. German soldiers watching Crabs operate for the first time struggled to process what they were seeing. The concept of deliberately triggering mines rather than avoiding them seemed to violate basic military logic. The spectacular nature of the operation, chains whirling, earth flying, continuous explosions, created an impression of unstoppable momentum that affected German morale beyond the actual physical threat. One German report filed from Normandy specifically mentioned the British mine-clearing tanks. The enemy possesses specialized armor that can cross minefields by detonating them. These vehicles lead every attack, clearing paths that our obstacles cannot stop. Defensive positions prepared around minefield coverage are compromised immediately when these machines arrive. Conventional anti-tank weapons can engage them, but must compete with the dust and debris the flails throw up, which obscures targeting. The psychological effect on troops is significant. When obstacles they've relied on prove ineffective, defensive determination weakens. The technical performance exceeded even British expectations. Crabs operated effectively in the bocage country inland from the beaches, where soft soil and hedgerows should have complicated their employment. They cleared paths through flooded areas where mines had been planted in waterlogged ground. They continued operating after taking direct hits from German anti-tank guns. One Crab documented to have cleared the final 50 meters of a minefield while missing several armor plates and with its radio destroyed. As British and Canadian forces pushed inland, Crabs became essential to maintaining offensive momentum. Every defended village, every prepared strongpoint, every river crossing featured German minefields. Conventional clearance would have required time and casualties that would have slowed the advance unacceptably. Crabs simply drove through the obstacles, their crews accepting extraordinary risks to keep following forces moving forward. The Siegfried Line, breaking the unbreakable. The approach to Germany's border fortifications, the Siegfried Line or West Wall, confronted Allied forces with defensive obstacles representing years of engineering work. Concrete fortifications, anti-tank ditches, dragon's teeth barriers, and extensive minefields created interlocking defensive zones designed to stop or severely delay any attack. German propaganda had emphasized the West Wall's impregnability. German soldiers defending those positions believed their obstacles would extract massive casualties from attacking forces. British operations against the Siegfried Line employed crabs as primary obstacle-breaching assets. The flail tanks advanced directly into minefield belts that German engineers had positioned to stop armor cold. Following the crabs came specialized armor equipped to deal with other obstacles, bridge layers for anti-tank ditches, fascine carriers to fill gaps, armored engineering vehicles to clear debris. The combined arms approach transformed seemingly impregnable defenses into obstacles that could be breached within hours rather than weeks. The operations against the West Wall demonstrated mature British doctrine for employing specialized armor. Crabs didn't operate independently, but as part of combined arms teams that could overcome multiple obstacle types in sequence. Infantry protected the specialized armor from German infantry with anti-tank weapons. Artillery suppressed German defensive fires during critical breaching operations. Conventional armor exploited breaches the specialized vehicles created. The system worked because each component performed specific functions that complemented the others. German forces defending the Siegfried Line found their carefully prepared obstacles systematically defeated. The minefields that should have stopped British armor for days were cleared in hours. The concrete fortifications that should have required sustained bombardment were outflanked once the minefields protecting their approaches were breached. The entire defensive system, designed around the assumption that obstacles would buy time for mobile reserves to respond to penetrations, collapsed when obstacles could be cleared faster than reserves could reposition. One German defensive sector commander, captured after his position was overrun, explained the psychological impact. "We had been told the West Wall was impregnable. We had inspected the obstacles ourselves, the mines, the ditches, the fortifications. We believed we could hold for weeks at minimum. Then the British arrived with their specialized tanks. The mine flails cleared paths through our fields in full view of our positions. We fired at them continuously, but couldn't stop them. When our minefields were breached, we knew the other obstacles would fall shortly. Troops began surrendering before their positions were actually penetrated because they understood the defenses had failed." The Siegfried Line breaching operations cost British forces casualties and damaged equipment, but the results validated the specialized armor concept completely. Obstacles that should have stopped armored advances for weeks were penetrated in days. Casualties were substantially lower than conventional breaching would have required. German forces withdrew from positions they'd believed defensible specifically because British capabilities exceeded what German defensive planning had anticipated. What the Germans really thought. German military reports and prisoner interrogations provided extensive documentation of enemy perspectives on British specialized armor. The consistent themes were surprise at the capabilities, respect for the crews operating them, and recognition that German defensive planning had not adequately accounted for these systems. Tactical-level reports from German units engaged by British forces frequently mentioned the mine-clearing tanks specifically. The descriptions revealed both technical recognition of what the vehicles accomplished and psychological impact on German soldiers who'd relied on minefields for protection. One report from a panzer division fighting in the Reichswald stated, "British mine-clearing tanks advance at the front of every attack. They clear paths through our defensive minefields despite heavy fire. Infantry and conventional armor follow immediately in the cleared paths. Our planned defensive fires become ineffective because attacking forces can advance along routes we had not anticipated them using. The psychological effect on our troops is negative. Soldiers lose confidence in defensive positions when the obstacles protecting them are cleared before their eyes." Higher-level German assessments recognized the broader implications. A Wehrmacht report analyzing Allied offensive capabilities noted, "British forces employ specialized armor that provides them advantages in breaching operations that our forces cannot match. Their mine-clearing tanks, bridge-laying vehicles, and other specialized equipment allow them to overcome obstacles more rapidly than our planning assumed possible. This creates operational tempo that prevents effective defensive responses. Our forces lack equivalent capabilities and cannot field comparable systems given current resource constraints." German officers captured during the final months of the war provided particularly candid assessments during interrogation. One regimental commander stated, "The British specialized tanks were more important to their success than superior numbers or firepower. We could fight their conventional armor on relatively equal terms. We had no effective answer to vehicles designed specifically to overcome our obstacles. When they brought mine-clearing tanks forward, our minefields became useless. When they brought bridge layers, our anti-tank ditches stopped nothing. Our entire defensive doctrine assumed obstacles would buy time. The British specialized armor meant the time we bought was measured in hours rather than days." The cumulative German testimony revealed an enemy force that had been genuinely surprised by British capabilities and had failed to develop effective countermeasures. German defensive planning throughout the latter half of the war continued to emphasize mines and obstacles, despite mounting evidence that British forces could clear them rapidly. This represented either failure to adapt to new realities or recognition that Germany lacked resources to completely revise defensive doctrine. The inevitable conclusion: by spring 1945, German forces defending their homeland faced British armor equipped with specialized vehicles that systematically defeated every obstacle German engineers could prepare. The carefully planned defensive belts, the extensive minefields, the reinforced positions, all proved vulnerable to combined arms teams built around specialized armor like the Sherman Crab. The dancing tank that German soldiers had mocked in Normandy had become the vehicle they feared most. Not the Churchill with its heavy armor, not the Cromwell with its speed, but the ungainly Sherman with chains flailing from a massive drum. Because that vehicle meant their minefields were useless, their obstacles were irrelevant, and their defensive positions were compromised before the fighting even began. The Sherman Crab looked ridiculous. It moved like it was damaged. It made noise that attracted every enemy weapon. It performed a mission that seemed suicidal, deliberately driving into minefields and triggering explosives. But it worked. Through mud and rain and enemy fire, through forests and flooded polders and border fortifications, it cleared path after path through obstacles that should have stopped armored advances cold. British infantry and armor followed those paths, advancing at speeds that German defensive planning had never anticipated. And in the end, it proved that sometimes the most ridiculous-looking solution is the one that works when everything else fails. Because the Sherman Crab didn't look like a weapon that would change the war. It looked like industrial machinery accidentally attached to a tank, but it cleared minefields under fire, kept British offensives moving forward, and convinced German soldiers that no obstacle could stop British armor when those dancing tanks appeared at the front of the advance.